In this next part, we're trying to take a vertex and use that to put it into vertex form. As a reminder, our vertex form equation would be y equals a x minus h squared plus k, where hk is your vertex. You can see that has moved left or right, up or down to get to that vertex. So we had previously found these vertices for each one, or vertex for each one of the quadratic functions. So we just want to take this and put it into vertex form. We have a standard form equation where ax squared is 2x squared. So a is 2, whether it's vertex form or standard form. So this is going to say 2 parentheses. And we're moving to this vertex. This vertex had to go -2, which is left 2 and up 4. That makes that x plus 2 squared minus 4. If we're using this as hk, if h is -2, that'd be x minus -2, which is the same as x plus 2. And then plus k plus 4, sorry, that should be plus 4. So our vertex form equation would be 2x plus 2 squared plus 4. And b, g of x, has a value of -3. So we're going to put -3 out front. And then x minus 3 squared plus 51. This vertex shifted right 3 and up 51. Even for C and D, where we don't have something that's as nice because they're fractions, we can still put that into vertex form. And it doesn't even have to be a fraction. It could be a really ugly number or a really ugly decimal and still be a valid vertex form equation. So this has -2 as the a coordinate, or a value. So x plus 5/2 squared, because you're doing x minus a -5/2. And then subtract 7/2 out here. And for D, P of x equals -3 x minus 5/2 squared minus 13/4. There are other ways that you can go from standard form to vertex form. So that's often another question that students ask. And so this is not the only method. There's another one called completing the square. I don't typically teach that method for this particular class, but you're welcome to use it if you want. There are other videos and resources that teach how to do completing the square, and it can be helpful as you get to Math 172 when you do some of the trig things, especially as you start looking at conics. But once we know something is a maximum or minimum value, once we know a vertex, we can find the maximum or minimum value. So using what we had just found, in that first function, 2x squared plus 8x plus 12, the vertex was -2, 4. And since a was positive, the parabola opens up. That means that we're going to have a minimum value. So an upward facing parabola has a minimum. That minimum y value is -4. This minimum occurs at x equals -2. So this should hopefully ring a few memories about finding relative max and mins from a graph. If we're looking at this equation, p of x, that's the fourth one that we had previously done. The vertex was 5/2 -13/4. Because a is negative, our parabola opens down. This is going to create a maximum. So we have a maximum value of -13/4. This maximum occurs when x is 5/2. As we look at x and y-intercepts of a function, this is just a general reminder of what a y-intercept is. It's when the graph crosses the y-axis, and that point's going to look like 0 some value for y. So this is the value of y when x is 0. Let's find that for this first function down here. we have 2x squared plus 8x plus 12 again. So if I find f of 0, the value of y when x is 0, that'd be 2 times 0 squared plus 8 times 0 plus 12. This is going to be 0 plus 12 is 12. So our y-intercept is 0, 12. And this is a coordinate, so we're going to write it as an xy coordinate. The x-intercept is the value of x when y is 0. So this is when it crosses the x-axis, which is at x, 0, some value of x, and the y is always 0. It's possible that a graph has more than one x-intercept, but it's also possible that we don't have any real x-intercepts. So when we're trying to solve these, we need to think back to the types of graphs that we've seen. We have found quadratic functions that hit maybe twice on the x-axis, so that would have 2 x-intercepts. We've also seen functions that hit maybe only once, so that has 1 x-intercept, but maybe it's still going up and never hits the y or the x-axis, so that has no x-intercepts. For this one, if I try to figure out when y is 0, I'm going to do 2x squared plus 8x plus 12 equals 0. And then we'll try to factor this. This is how we normally solve a quadratic function. I'm looking across those 3 terms and see that there's a GCF of 2. So if I pull out the GCF, it's always going to make this factoring a little bit easier. That leaves me with 2 times x squared plus 4x plus 6. And then we can see if we can continue to factor this. X squared came from x times x. And we look at factors of 6. That might be 3 times 2. But if I check the inside and outside, I'm going to get 5x, and that's not 4, so that's not going to work. So maybe we change this around and make that a 6 and a 1. But using that one, that's 6x and 1x, that's still not going to give me a 4x. So what we see is this is not factorable. Not everything is factorable. So if I cannot factor, we're going to need to use the quadratic formula. So the quadratic formula will be in this next video, and we'll look at how to simplify something like that.